So up next, we've got Emma Hodcroft and Cornelius Roemer, who will be discussing all of the changes with the lineages in monkeypox and what Nextstrain has been up to.
So hopefully you can hear me, okay?
Yep, that was good.
Okay, wonderful. I'm just not so used to Cisco, so just checking. So I'm going to try and take just the first few minutes of this talk to give a quick overview of Nextstrain, and then Cornelius is going to cover Nextclade, and I also wanted to talk about the monkeypox lineage designation as well. So this is going to go a little fast because we're going to try and fit 2 people in, but we're happy to take questions and discuss more in the chat. So first of all, I just wanted to cover to make sure for anyone who isn't aware, we do have monkeypox builds on Nextstrain. They've been referenced a couple times already from the main website. You can see them down here at the bottom. And if you click on this link, it'll take you through to the builds. We actually have 2. And I'm going to start off by just showing this one first, but you can toggle between them. If you look at the top left hand, you can toggle between the 2 builds that we have. I'm starting out with the MPXV build, and this is essentially the zoom out. So this is one that shows the whole diversity of monkeypox, including clade 1, clade 2A, and clade 2B. And so here we can see some of the things that we've already been touched on. For example, the mutational differences that have happened more recently in the clade 2B that are, of course, of great interest right now and that some people have already touched on. But of course, because of this, there's a lot of interest in this clade. So we do have a focal build that zooms in on this. Before I switch to that, I just want to also point out that the Nextstrain builds are made with open data. And so this means that we can redistribute. So for example, we curate all of this data. We had a lot of practice with data curation during the pandemic. We've put in, I feel like, a lat long for just about every single place in the world. So we're pulling on that experience and that data to clean up the data that we download from the INSDC databases, and that's all made publicly available, including alignments, if you'd like to reuse those for your own analysis. But the next build we have just zooms in on this part of the tree. So this is what that looks like, and you can see that we now have a lot of kind of focus on the B1 outbreak, but we also do have, of course, like the A2 clade that Banu Jolly just spoke about so interestingly, and a very new, sorry, funny pop-up about annotation, a new lineage that's actually part of that, that's the A.2.1 lineage. And of course, as with every Nextstrain build, you can do things like filter the data. So if you want to look at a particular lineage more closely, you can turn filters on and off, zoom into those, you can click on tips to find out a little bit more about them, or mouse over branches and also shift click to see more about, for example, the mutations that we see. And of course, if you have any specific questions about this, our workflow is also open and we can answer questions. We also have, I'm just going to flash this up briefly, that we have what we call a big build. So this has about twice as many genomes. We don't downsample it. And in particular, we know that this can be really useful for countries if you need to see all of your sequences. For example, for making a report or just to see how they're connecting to each other. This is a way that you can see that. This isn't a stable URL at the moment, but we're hoping to get something up a little more permanently, and you're welcome to look at this for as long as it exists because we know this can be useful. So with that really, really fast introduction to Nextstrain, I'm actually going to now switch gears really fast and switch over to lineage designation. So some of you might already be aware of this. This is something that came out of the publication that already was flashed up once today, which was the urgent need for non-discriminatory and non-stigmatizing nomenclature for monkeypox viruses that involved a wonderful group led by African scientists, but a really international group, to try and rename what were previously geographical names for the 2 clades of monkeypox that are now clade 1 and clade 1A and clade 2B. Sorry, clade 2A and clade 2B. With the idea here really being to get together some scientists to try and rename this. This proposal outlined some initial names like these clade 1 and clade 2, but also set up an idea that we should continue coming up with names for increasing diversity and parts of the monkeypox tree that would be useful to talk about. So many of these scientists have come together to form a more international group to continue to give names as we see new diversity and new sequences coming up in monkeypox, to hopefully aid talking about these clusters of viruses more easily. One thing I wanted to really emphasize is, even though this is definitely a project that's Nextstrain involved, Cornelius and I are here to talk about it today, and a lot of this we use the Nextstrain trees. It's not a Nextstrain project. It's very important to us that this is something that This isn't something that Nextstrain has control over. It's an international group of scientists, and we really value input both from other scientists and from the public as well. As with all science these days, this is mostly something that happens on Slack, Twitter, and GitHub. And in general, we've focused on Clade 1 and the outbreak in particular, but we aren't necessarily limiting ourselves to that. That's certainly where most of the sequences, most of the interest, and most of the need is right now. And the names that were designated are inspired by the same Pango style that you'll know from SARS-CoV-2. So that's the letter numbering and then the aliasing. One difference is we do an alias after 2 subdivisions instead of 3, as you see with SARS-CoV-2. Then the upsides of the Pango style naming, it's really easy to expand. You can always have a C or a D or whatever. It's very easy to take out. We're all a little bit used to it, and it's something that's very flexible and completely disconnected from any kind of preconceptions. But in general, also, our main goals here are to give names to things to help make communication easier so that people don't have to use shorthands, especially ones that can be stigmatizing, geographic, or even inaccurate. Or, we were hearing some things about this is the clade that's associated with this particular event or this particular activity. And this can be unhelpful, especially if it goes into the wider media. And one of the things we're really, really focused on is trying to be transparent, community-focused, and useful and usable. So this feeds directly into how we're designating these lineages. At the moment, our criteria, which of course we don't know what the future might bring, this is an ongoing outbreak, so these may adjust, but they've been served us pretty well so far, are that a lineage has spread internationally, has at least 1 mutation above its parent, contains at least 15 sequences, or represents undersampled diversity, because we know that this can be something that is a challenge. We want to still give names to things that are useful or of interest, even if they don't have enough sequences quite yet. We're also trying to just name things that have clear structures. So we try and wait if it's not clear if something would be 2 or 1 lineage, so we don't have to have renaming or complicated kind of non-intuitive naming, and has at least 1 freely available high-quality reference sequence. And this is really because it's very useful to have these milestones that we can put down in a phylogeny that are openly shareable, easy to talk about. You can list all of the mutations so that everyone knows where they stand when we're talking about a lineage. You know exactly what that means. You have a reference that you can go to. This is very useful for good science and kind of easy communication. And so far, this has led to designating 9 outbreak lineages and 1 8.2 lineage, the 8.2.1 that I spoke about a little earlier. You can find us on GitHub and Twitter. So on Twitter, you can follow us. We always tweet when we have new designations, like this morning. And on GitHub, I'll just go to the GitHub really quickly. You can find a human readable lineage summary that describes all of the reference sequences, SNPs, and a little bit about each lineage. This is also machine readable, so you can find files for each lineage that you can read in computationally and find out about each lineage. And whenever we designate lineages, we also write up a very brief little report just saying why they were designated and what we knew about them at the time. And with that, I'm going to stop sharing so that Cornelius can take over and tell you a little bit about Nextclade.
All right, so Cornelius, I've just passed this on to you.
Yes,
Present.
I will take over. I think you should be able to see the screen now. Very good. So one question that obviously arises when we start designating lineages is, you have your sequence and you want to know what actually is, which lineage does your sequence belong to. And that's what you can use Nextclade for. So Nextclade was initially designed for SARS-CoV-2, which is usually what you see when you enter the URL. But I can show you how you can switch to use it for monkeypox. You click on the change button here, and then you scroll down, and we have right now 3 different data sets with different zoom levels. So the all clades one is if you, for example, want to assign clades to sequences that might be from all clades. But if you're doing some routine surveillance right now, it's much more likely that you will have sequences that belong to the current outbreak lineage B1, or sometimes maybe these A2 lineages. So I recommend you use this HMTXV build as default, and it will tell you when you have something that doesn't belong to it. I will show this in a second. So you can click on here and then upload your sequences, or you can load an example to be able to just see the functionality without uploading any sequences yourself. And I've kind of already run it. It doesn't take too long, but because we're short of time, here we go. And so, for example, here is exactly what I mentioned. You can see that this sequence is not part of human monkeypox 1. So it's in the out group, and here it would be beneficial to run it on the all clades build. But for all the other sequences, you see they belong to HMPXV1. And you can see the lineage here. I've sorted by the lineage to make it a bit easier to see. And so you get the lineage. And we also have certain QC metrics which aren't particularly well defined yet because monkeypox has been sequenced very long. But one thing that's quite useful, I think, for sequences is our reversions that we highlight. So something that we've seen is that sometimes some workflows that are used, they fill unknown mutations or unknown positions with the reference. And so depending on what reference is being used, you will see basically that some SNPs are back to a reference that they shouldn't be. I can show this on a tree in a second, and this is usually a quality problem. So if you hover over the mutations, you can see the reversions. There are quite a few here. That usually means you should look into what your workflow is doing. If we look at the tree, if you click at the top right, you can see the sequences you uploaded placed on a current phylogenetic tree. And for example, what we see here is that there are quite long branches leading to a lot of these sequences. And they, in this case, if you hover over a branch, you see that it's the same mutations coming up time and again. So that is suggestive of an artifact. So it would be good, if you sequence, just to drop your sequences in Nextclade and see if you spot any patterns that are unexpected, and then maybe fix them. Of course, when we notice something, we reach out to submitters and are in discussions on how to work towards better quality sequences. I will quickly show what Nextclade looks like if you use another data set. So this is the all clades data set, and you see that you have many more mutations here in the view. So this is less helpful if you're dealing with sequences from the current outbreak, but it is able to assign clades 1 to A and to B. So that's useful, especially for if you want to run Nextclade, for example, to create reports or run it on the CLI. And this is, if you use the B1 focus build, you can see that it's much easier to pick up single SNPs and spot some patterns. The disadvantage of using this build is that you cannot see reversions well because there is no concept of A1 in here. The root is equal to the outbreak founder. And so it's probably best to use this HMPXV1 build that's in the middle if you're using your own, if you're using it for QC. All right, I think we're running out of time. So if you have any questions, feel free to get in touch with us on Twitter, or there's a Nextclade discussion forum where we're happy to answer questions too. In case you don't know it, it's discussion.nextstrain.org. And we're happy to take it from there. Thank you.